Good morning, everybody. I'm Chun from Zhejiang University, and it's a pleasure to be here and share our research with you today. So, as you can see, it is about integrating knowledge modeling approach and knowledge graphs for in the contract risk identification or contract review context. So let's first take a look at the background. According to 2023 Global Construction Dispute Report, the average construction dispute value has risen from $30.1 million to $40.8 million, where the poor contract management is a major cause. While most of the contract review are still done manually, which is not only time-consuming, but also heavily rely on the expert's personal experience. That's why we need the automated contract review tools. So, natural language processing, aka NLP, has been frequently introduced as a technique to automate this process, and they can be broadly classified into rule-based, machine learning-based, and deep learning-based approach. So, rule-based approach define rules such as if the subject and the verb, the object, each belongs to certain class type, then then we determine the class has a risk. While deep learning-based method, they requires annotated data set to fine-tune a pre-training model like BERT. So the model learns the pattern, and they can predict new risk labels on the new data. So these approaches has been proved to be successful in the given task, and mostly classification task. But the problem is, first, they only look at the one sentence at a time, which can neglect the context and the interconnected relations in the rich contract context. And second, the pre-train and fine-tuning pattern also relies on a large amount of high-quality annotated data, which makes them lacks in flexibility and scalability. So to challenge the old pattern, we want a method that can not only predict the fixed labels, but can also output risk reviews. That's where a large language model comes in. They have this strong in-context learning ability, which then can allow them to process and apply new information based on few or no examples. Therefore, they are quickly adopted in many areas such as medical, legal, and so many other domains. But the question is, can we trust their output with the hallucinations issue and with the factual inaccuracy? Because these issues are inevitable, the language model output are based on probability. But there are potential solutions, such as providing them with the granular, contextually relevant and precise external knowledge to enhance them, to recall the essential information and reduce the hallucinations. In this study, basically, we want to answer the two questions. First is how to represent the contract knowledge with knowledge graphs, since they are complex and rich in semantics. So a knowledge graph modeling approach is proposed. And second is from the knowledge augmentation side, how to explicitly integrate these structured knowledge to enhance the knowledge-intensive task, such as automatic contract review or others. Well, now we want to model the contract knowledge with knowledge graphs, and a basic unit of a knowledge graph is a triple, as you can see here. So the head node denotes the subject, and the tail nodes denote the object, and the edge connecting them denotes the predicate. And that's a structure of a triple. For example, we want to see the project manager approve the proposal, then it can be represented in this triple. But contract knowledge is more complex than that. What if we want to also know the end date of this action, or we want to know the condition of conducting this action? Well, in this way, we can consider the whole triple as a node and connect it to other node like this. So in this way, we can redefine the elements in a knowledge graph. The original triple is an entity-to-entity triple. And when we consider the triple as an integral part, where we name it a fact node. So when we link the fact with other like entity constraints, it can form the entity-to-fact node. And we also have the fact-to-fact node, which represent maybe temporal relations or conditional relations between two actions. And so principally, this framework can represent multi-layer nested data, but also considering the scalability, we only test the one-layer nested data. So we represent such metadata using RDF star language. Now, on top of the data modeling structure, we define the contract ontology, where we fill in the contract domain knowledge, and we define the classes and subclasses, where you can see the basic elements classes are contract actor, contract object, and contract property, constraints, etc. And we also define the classes for the fact, such as behavior, statement, and under them we have the subclasses, the inclusion, submission, etc. And I will not elaborate them here. So, and on the other side, we present the process of extracting such knowledge from unstructured text, following the entity identification, fact identification, and relation linking process. Finally, they can be represented in the RDF star language here. And also in this study, we use the standard form of construction contract, such as FIDIC, and you see as an example knowledge base. So they are constructed and transformed to RDF star using following this process. So after the knowledge graph is constructed, we present the knowledge augmentation pipeline. Compared to the baseline, which is maybe directly ask ChatGPT, can you analyze the risk in the clouds? In our approach, we define this pipeline that taken contract clauses input, language models will first generate questions regarding what knowledge is needed in this task, and that query will be translated into Sparkle query to retrieve task-aware knowledge from the contract knowledge graph that we constructed, and then knowledge will be fed back to language models along with the original clauses and the task instructions to enhance this process. And to validate and further clarify our approach, we present a simple case study where a contract clause from an EPC project is input for the risk identification, and it states the provision about advance payment. So it states the percentage, the amount shall be amortized, and the condition, blah, blah. And it's actually a reasonable provision. So expert will identify no risk in it. But we found no matter you ask ChatGPT or GPT-4, they will always tell you there is a risk. So if you see the baseline output, it's some random and some nonsense, doesn't make sense. So according to our approach, we generate the questions. In this case, it need the definition of the term advance payment guarantee and the condition of making such payment. So this question is transformed to the Sparkle query, and it retrieves the triples stating the fact. And after giving this knowledge back to language models, it modify the answer to the correct answer. And there are limitations. So the case study is still simple and limited. More clauses and more scenarios are to be tested. And also the current knowledge graph construction is still mostly manually, and more knowledge resources and other knowledge augmentation pipeline should be included. Finally, the more feasible evaluation metrics is yet to be developed, especially for the language model generated free-form text. So I hope I'm not passing the time. Thank you.